Hello everyone. Hope I am audible. Can one of you please comment so that I can understand that I am audible as well as you can see my screen? Okay. Thank you for commenting out. Uh, so today this is the first class of theory of computation. So we have started a new crash course for only for the GATE 2023 candidates, and along with that, you know that we have our GATE mock test that is live in the GeeksforGeeks website. So please do attempt there. And today, we'll be discussing about the regular grammar, and we'll be solving some of the gate questions into it. And so let's stay. Let's start the class. So if you have any questions or any doubt, please comment in the live chat so that I'll come up with your question. So let's start the class. So first, before going to the examples, let's start with the introduction, and we'll start with the bit of different terminologies that we use to define a regular grammar language or specific DF. So we'll start with symbol. So first of all, what is symbol? So symbol is any character. Symbol is any character like A, B, C, or maybe alpha, beta, or maybe 0, 1. Any character that we use to represent a specific I mean for a specific transition or something, we use these characters. Okay, this each character is known as the symbol. Okay, now what is alphabet? Alphabet is basically the set of symbols. Okay, so suppose we are telling that we have A and B in a set, so that is called alphabet. Okay, maybe we can say that our all uh, English characters are there into a set. Okay, so this is alphabet. Alphabet is means that the symbols that we can use throughout our construction of the regular grammar or language or DFN. Okay, then comes string. So what is string? String is basically the collection of symbols. You see, I mean the the stream of tokens that we can use by using the given symbols that are available in the language. Suppose you have been told that in a language you can use only A and B. Okay. Now, what are the strings that are possible? The strings are possible only A, maybe only B, then A, B A, B B. These are the strings that are possible. So these are like length 1 string, these are length 2 string. Then we can come up with something length 3 string, then maybe length 4 string, anything. Okay. So whatever the bit of tokens we can make using the given symbols in our alphabet. Okay, so those are called the strings, and the length of the string is mentioned something using this. Okay, mod of this. It means we are telling the length. So for these two string A and B, the length will be 1. For this 4, the length will be 2. For this, the length will be 3. For this, the length will be 4. Okay. Then let's come to language. So a language is basically the collection of strings. Okay. So collection of string means, suppose I am telling that in our language it is accepting the strings which are having length 2. Okay. Strings of length equal to 2. So if in a language we have all the strings which are having length equal to 2, then what will be the language? The language will contain basically these 4 strings, right? A, AB, BA, BP. So these 4 strings will be there into our language L. So let me repeat everything. So symbol is just a single character or single entity. Then alphabet is a set of characters, a set of unique characters that we'll use to represent our input string or our output string. Okay. Then string is what? String is the set of symbols. Okay, I mean, if you use the symbols, and after using, if you are making a bit of I mean stream of tokens or stream of symbols, then that will be a string. Okay, and language is the collection of strings. So given the specific rules, the language will be all the strings that are inside that language. Okay, suppose here the main I mean language, or the main thing was that it will be a collection of all the strings which are having length equal to 2. Okay. So in our language, if we can see, we have these 4 strings. Okay. So for any question, you can just you know just put into the live chat so that we can understand. Fine. Let's move ahead with our basic introduction to DFA. Okay. So in our basic introduction, basically we will be drawing a DFA. Okay, what the deterministic finite automata is and how does it look like, and finally we will move into some examples. So first thing is that in a DFA is what? DFA is deterministic finite automata. So basically it is a machine, okay, which takes an input, and I mean input as a string, and it tells that whether that string or the input belongs to that specific language or not. Okay, I mean for every language you are creating a finite automata. Okay, and now after taking the input as a string, you need to tell whether that string is inside the language or not. Okay, so for that, if we take the diagram, it will be something like you are providing a string, okay, and you have some finite model here, finite model. Then how did you create the finite model? You have created it by the concept of language. And whatever the rules and regulation are in the language, so using that we have created the finite model, and by inputting the string, it will tell us that whether the string is in the finite model or it is not in the finite model. Okay. So that is the basic idea over making this finite automaton. Okay. So after this part, so that is the basic I mean thing. Now let's take a specific example where like I will draw a finite automata. So suppose we have certain states. We have certain state A. Then by getting the input character, suppose by getting a character B, it will go to state C. Okay, state C. By getting another input, we are going to state, suppose state B. Okay. And suppose these two are self loops. By getting any other input A or B, it will be into the self loop. Okay, so this is like a basic diagram of a deterministic finite automata. So here you will be having certain states like A, B, C. Now I can say that maybe B is the final state. Okay, final state is a certain state in which if by any input, if we are going to the final state, or if we are staying in the final state after scanning through the whole input, then we can say that okay, this string is accepted. Okay, so I'll come up with the detailed explanation, don't worry. So here for this specific case, we have 3 states. We have state A, state B, state C. Among them, state A is basically the initial state, and state B is basically one of the final states, right? And in our alphabet, we can use only 2 symbols, A and B. You can see I have used only A and B in different cases, right? So this is like a basic diagram of a DFA. So let's move on, and I'll explain this example in a bit clearer. So in the introduction of DFA, so firstly we'll represent that how a DFA is represented using tuples. Okay. So for DFA we have a 5 tuple structure. So each tuple will be having this set of states that is represented by Q, set of alphabets, then transition function, okay, then initial state, set of final state. Okay, so these are the 5 tuples or the 5 symbols that are used for, so 5 tuples or 5 symbols that are used so that we can represent our DFA here. Okay, so let's see how does it look like in terms of the example we had given before. So we had told that there will be one initial state, and upon getting the character A, we are going to a final state. Okay, upon getting character B, we are going to another final state. I mean, we are going to another state, and these two are set. Okay, now I'll tell that. I mean, how we can represent this finite automata in terms of tuples. Okay, so Q, as I told that Q is set of all the symbols, right? I mean, Q is the set of all the states, the representation of the state, right? So basically, here we have 3 states A, B, and C. So A, B, and C will come here. Fine. Now, this I told that it will be the set of the symbols that we are using. So mainly alphabet, right? So for this case, our alpha, I mean, what are the symbols that we are using? The symbols are small a and small b. Okay. Now we have set of production rule. I'll come up for that in some time. And Q0 is the starting state that we can see that we have a starting state as A. Okay, so Q0 is A, and F is the set of final states. Okay, now we have B as a final state, so it will be set of final state. Okay, so remember I am telling that F is basically the set of final states. Okay, it means it is possible that there can be multiple final states. Okay, and F is, I mean, then B is one of them. Okay, for our this case we have only one final state, so that is why we are writing B only. But it is possible that there can be multiple final states. Okay, so now let's come to the production rule. The set of production rule. So what is that? Production rule is basically this Q cross sigma. It will go to another. Okay, this is the rule. So what does it represent? It represents that we are in such a certain state. Okay, this Q is basically containing all the states, and uh, this one, the sigma, is basically, you know, all the input alphabets. Okay, all the alphabets or characters. Uh, all the symbols that we can use. Okay, so and given one state and one alphabet, we will be going to another state. Okay, that is the main purpose, right? Now you can see we have 3 states A, B, C, and we have 2 input symbol. Okay, and we will be going to ABC. So what are the possible left hand side things? So the possible things are we are in state A and we have got the input as small a. We are in state A, we got the input as small b. We are in state B, got as A. We are in B, we got input as small b. We are in C, state C, we got input as small a. And we are in state C, we got input as small b. Okay, so these are the 6 possible cases if we do the cross product here. Okay, now depending on the DFA, we'll write that what are the production rules. Okay, so we are in state capital A and we are getting the symbol as small a. Okay, so we are in capital A, we are getting the symbol as small a. Then where we are going? We are going to state capital B. Okay, next we are in capital A, we are getting symbol as small b. So where we'll reach? We'll reach to state small I mean capital C. Okay. Then we are in B and we are getting A or B. Okay. So even, I mean, if we are getting A or if we are getting B, in both cases we will be staying into the same state because we can say that it is a self loop, right? So upon getting the input symbol, it won't change its state. So B, A upon B will go to B itself, B upon B will go to B itself, and same goes for C. C upon A, it goes to C, and C upon B, it goes to C. So these are the 6 possible production rules that will be there into the set of the set of all the production. Now the thing is that how the DFA basically accepts a string or rejects a string. Okay. Now let's say I'm telling that I have 2 strings. One is ABB, another one is BAA. Okay, so let's see how they are being accepted or not. Right. So first let's start with ABB. So we will always start with the in the state A. Okay, I mean our initial state. We'll always start with our initial state. So we are in state A. Now we'll get our first input, that is small a. Okay, so we are in state A. We are getting our first input, that is small a. Then where we'll go? We'll go to state small b. So here you can see that from A we're getting a small a, and so we'll go to small b. Right. Okay. So we'll go to small b. So we have scanned this first symbol. After in small b, we'll again get a, I mean, in the state capital B, we'll again get a small b as the input symbol. Okay. So in capital B, if we get a small b, then where we'll go? See, here is a production rule. In capital B, we are getting a small b, we'll reach to again capital B. From here, again we are left with another symbol. Okay. So from capital B, upon getting a small b, we'll be in the state capital B. Okay. Now you can see that starting with the initial state, by scanning the whole string ABB, we will be reaching to a final state. Okay, we will be reaching to B, which is a final state, right? That means this string is basically accepted. So I mean starting from the initial state, if we are reaching to the final state, then we can say that this string is accepted. Okay. Now let's check for the next string. So from the next string, starting with the initial state, you can see from A, if our first symbol is B, we'll basically reach to the state C. Here is the production rule, right? We'll reach to state C. From C, again, if we get A, we'll be into the same state C. So here you can see that it is a self loop basically, right? And again, if we get B, we'll be into the same state C. Correct. So you can see that upon scanning the whole string, we are going to a state. Okay, we are going to a state C, which is not a final state, right? So if this is not a final state, then what we can see? So we can tell that starting with the initial state, upon scanning the whole string, we are not going to the final state. That means it is basically, this string is not accepted. Okay, this string is not accepted because we are not reaching to a final state. So this is a very important criteria that upon scanning the whole string, we should be reaching to the final state. Okay. So here another concept that is you can visualize if you see correctly. That is, if we are reaching to the state C, okay, just I mean pay attention. If we are reaching to the state C, then we cannot come back. Okay, I mean upon getting all type of inputs, we cannot come back to state A or state B. Right. So this state C, this state C is called the dead state. Okay. State C is called basically the dead state because from C we cannot come back to state A or state B. Okay. So is this making sense? Is this clear? Can you please comment out? So C is not final state. That is defined by me. Okay. I mean, in the language itself, it is given that. I mean, see, this DFA we have taken this DFA as arbitrary, right? This is one of the arbitrary DFAs. So in DFA, suppose our condition is like this: that A is the initial state, B is the final step, and C is certain other states with these production rules. Okay. Now I'm telling that uh, see, this C is dead state because given this production rules, we can visualize that if we are going to state C, we cannot come back with any other inputs. We cannot come back to A, or we cannot go to the final step from that position. Okay, so that is why C is the dead state. Okay. Does it make sense? So there is another question. It is telling that does the crash course make us able to solve all question of gate? See, for this crash course, we will be discussing over the very important topics and we will be solving the previous year gate questions, some of the previous year gate questions. Okay, so you can take it as a very like starting stage of the preparation. So based on the crash course, you can just solve more previous year questions and you can just I mean increase the breadth of your knowledge so that you'll be able to solve all the gate questions. Okay, but it doesn't mean that I mean in the crash course we'll be solving almost all the gate questions. So we'll be taking the very important examples or very important previous year questions in the I mean crash course. Okay, and we'll be discussing over that. So that will help you in clear your concepts in a very deep way. Right. So if there are any more comments in the live chat, please put it there so that we'll understand. Oh, great. So let's move forward with certain certain basic things of DF. So I was telling that a string is said to be accepted by a finite automata. A string is said to be accepted by a finite automata if by scanning the whole string we'll reach to one of the final states starting from the initial state. Okay, so we discussed over it, right? I mean, given a string, we are starting from our initial state, and by scanning the whole string, if we can reach to the final state, then we will tell that that string is accepted. Okay, so it is telling the same that a string is said to be accepted by a finite automata if by scanning the whole string we reach to one of the final states starting from the initial state. Correct. So that is one part, and another part is a language is said to be accepted. A language is said to be accepted by a finite automata if the language accepts all the strings that are accepted by the finite automata. Okay. A language is said to be accepted by a finite automata if the language accepts all the strings which are accepted by the finite automata, and the language should reject the strings which are not accepted by the finite automata. Okay. So you can say that finite automata and the language should be equivalent to each other. So if a string is being accepted by the finite automata, that string should be into the language. And if a string is not accepted by the finite automata, that string should not be into the language. Okay. So these two cases, the string and the finite automata should be similar. Okay, should I mean the finite automata and the language, the string should be equivalent to both of them. Okay. Now let's move forward. Now from this point of time, we will be starting and we will be talking about different examples of DFS. So mostly we will be like looking into the very basic examples where given the language, here you can see that this language is told verbally, right? They are trying to, understand, or they are trying to provide the intuition that what are the strings will be there into the language. Okay. From understanding that part, we will be trying to construct our DFA. Okay, with some certain examples. I mean, this is the example one, and we can give more examples and more practice. This part will be very clear. Okay. Now, at this point of time, is that everything okay? Okay, great. So, basically, I'll start over the example. So, in our language, it is telling that construct DFA over AB with length at least 2. Okay, so we will be constructing a DFA and the alphabet is A and B with length at least 2. Okay, now with length at least 2. Okay, so first of all, we need to think that what will be the strings that are in the language. Okay, what are the typical strings that can be into the language? So the string length is at least 2, right? So the first string that can be possible, that is AA. Okay, the smallest string will be all the strings with length 2, right? So that is AA, AB, BA, BB. Okay, so these are the smallest strings that will be accepted by the constructed DFA. Okay, so after that, as they are telling that the length of the string should be at least 2, it means the strings with length 3, the strings with length 4, the strings with length 5, and so on, everything will be accepted, right? All other things will be accepted. Okay, so how to construct the DFA? So we'll be in an initial state. Okay, by upon getting any character, okay, by upon getting any symbol, we'll be going to another state B. Okay, and what this state B is representing? State B is representing that now we have scanned at least one symbol. Okay, either A or B, we have scanned at least one symbol. Right. Now again, if we get another symbol, either A or B, we'll go to state C. Okay. Now what state C will represent? State C will represent that at this moment we have scanned at least two symbols. Right. So at least two symbols are being scanned. So, like after scanning, we'll be reaching to the state C. Okay. Now we can see that if two symbols are scanned, then that string should be accepted, right? So C will be our final state. C will be our final state, which is accepting these two symbols. Okay. So this is for number of symbols are 2. Okay, the length of the string is 2, and it is telling that we should be accepting all the strings which are having length greater than 2 also. Okay, so we just simply will add a self loop. Okay, so even upon getting another multiple symbols, okay, even upon getting another multiple symbols, we will be staying into the state C, right? So that means we are ensuring that uh, all the strings with length 2 and all the strings with length more than 2, everything will be accepted and we will stay into the state C. Right? We'll be reaching to the final state and we'll be staying there. Is there any question? I'll just quickly check out the chat box. So I encourage you everyone to please register to the Gates AC Crash Course 2023. It's absolutely free for everyone, and I mean whoever has prepared most of the subjects and has almost at the end of the preparation, they can just use the crash course to understand, you know, I mean to revise the basic concepts on that. And even if you are not started or you are at the very beginning stage of your preparation, then you can also like register for the crash course. There you will get at least the basic idea of what are the things you need to prepare, what are the things that are most important. Okay, because we will be discussing over the only most important topics of each subject, right? So, and this course is absolutely free, so anyone can I mean register and understand the different things, different topics, questions that are being discussed over there. So, fine. Let's move on with our next example. So, it is telling, so it is basically the same example where only the difference is that in the last example we have told that it is of length should be at least 2, the length of the string should be at least 2. Now, uh, in this question, the length of the string should be at most 2. At most 2 means that the highest string that is possible, that will be of length 2. Okay. So, the length can be 0 also, the length can be 1, the length can be 2. Okay. After 2, if you are talking about string with length 3 or 4, this and anything else won't be accepted. Okay. Because the length of the string should be at most 2. Okay. Length should be at most 2. So, in that case, what are the strings that will be accepted? The strings will be 0, I mean null. The strings can be with length 1. The strings can be with length 2. Okay. So these are the 7 strings that will be accepted by this DFM. Okay. So let's try to draw the DFM. So null means our initial state is our final state. Okay. So whenever we need to like whenever we need to accept null for the length 0 string, in those cases we need to make our initial state as final state, because from where we will be starting, we should be ending there also. Okay. Then length 1, I mean if we are getting only one symbol, then that should be also accepted. Okay, we should be reaching to a certain state from where we can tell that this is accepted. Then if we are getting length 2, okay, then this state should also be accepted. Okay, it means basically this is of length 0. I mean the first state, that is suppose I'm giving as q1, q2, and suppose this is q3. Okay, so q1 is representing that all the strings with length 0. Okay, as it is the initial state also. q2 is representing that all the strings with length 1. Okay, q3 is representing all the strings with length 2. Okay, so after that, if after q3 we are getting any more symbols, then we should be going to a certain state from where we cannot go back. Okay, means this is our dead state. Suppose I'm just representing with the date state. So this state will represent that there are the strings with length 3 or greater than equal to 3. Okay, it means if you are getting a string of length 3, 4, 5, 6, 7, anything, then those strings won't be accepted in our DFA. Okay, so this is the date state, that from where we cannot go back to any of the final states. Right. So fine. Let's move on to our next example. That is saying construct a DFA over AB, but the length of the string is even. So what does it mean? Length of the string is even means 0, 2, 4, 6. So these are the lengths. These are the possible lengths. Okay. So it means our first of all 0. 0 means null will be accepted. Right. So if null is accepted, then what I had told, I told that if null is accepted, then our initial state will be our final state. Right. Then upon scanning one symbol, any symbol, okay, upon scanning any of the one symbols, we'll be going to a non-accepting state. Why? Because this non-accepting state is basically representing that now our length of the string is odd. Okay, because we have started with 0, right? Now we are at this state, it means that our length of the string is what? 1. Okay, and 1 should not be in the language. So this is one non-accepting state. From the non-accepting state, if we are getting another symbol, okay, from the non-accepting state, if we are getting another symbol, then we can tell that, okay, now our length of the string is even. Okay, hence we'll be uh, coming to the accepting state, or you can say one of the final states, right? So let's understand it a bit deeply. So we are starting with the length 0 string. Upon getting a single symbol, we'll be getting length 1 string. Then by getting another symbol, we'll get length 2 string. Then like this, length 3, length 4, length 5, like that. So you can notice that all the even length strings, okay, like length 0, length 2, length 4, all the even length strings are coming to the accepting state. It means these will be accepted, and all the odd length strings, those are going to the non-accepting state. Okay, so it means we are following the given condition in the language. Okay, now let's check out our next example. That is correctly the odd. I mean the perfectly opposite example, where it is telling that the length of the string should be odd. Okay, length of the string should be odd. So from this DFA, you can clearly understand that if we are taking the strings which are odd, then which one will be our final state? Okay, so just a quick question. That suppose we are having this state is suppose represented as Q0 and this state is suppose represented as Q1. Okay, so in the example 3, if Q0 is our final state, so which one will be the final state for example 4? Which one will be the final state in example 4? Yeah, it's the like correct comment that we can say that for this even length example that both initial final states are same. Yeah. So for the example 3, this Q0 is the initial state as well as Q0 is the final state. Okay. Now what about example 4? So for example 4, we have the same structure. Okay, same structure. This is Q0, this is Q1. Just tell me that which one will be the final state, whether it is Q0 or Q1. Any comments? Which one is the final state, Q0 or Q1? basically, as I told, that Q0 is representing the strings of odd lengths, the strings of odd lengths, and Q1 is representing, I mean, sorry, Q0 is representing the string with length even, okay, even length strings, and Q1 is representing the strings with odd length, with odd length. Okay. So for this case, as it is telling that where the length of the string is odd, that means Q1 will be our final step. Okay. So for the above case, Q0 was the final step. For this case, Q1 is the final step. And here you can say that initial state and final states are basically different. Okay. Initial state and the final state. So this is the DFA for the strings with length odd. Okay. But let's move on to our next example by telling that the length of the string mod 3 will be 0. Okay. I mean length of the string mod 3 will be 0. So if we take length, okay, if we take length and do it, I mean do the mod of 3, then uh, how many type of strings can be possible? Okay. There can be remainder of 0, 1, 2. Okay, these three states can be possible. I mean, for any number, if we just check that whether it's divisible by 3 or not, then these three remainders can be possible, and they are telling that for the accepting case, this remainder should be 0. Okay. For the accepting case, the remainder should be 0. It means this will be the our final step. So let's try to draw the automata. So it's like we have some state here, Q0 will go for Q1. So Q0 is basically representing, okay, where the remainder is 0. Okay, the remainder is 0. Then Q1 where the remainder is 1. Then Q2 where the remainder is 2. Okay. Now let's say by getting one symbol, we'll go from Q0 to Q1. In Q1, if we're getting another symbol, we'll go to Q2. And from Q2, if we get another symbol, we'll come back to Q1. I mean Q0, right? So here, what is our final state? Okay. So before going into that discussion, how did I make this automata? Okay. So see, here we are having, I mean, for any length string, if any length string, if we are just doing a mod over it, okay, we can get three type of results. Okay, one is the length 0, length 1, and length 2. And for this case, they are telling that the length should be 0. It means what are the strings that will be into this language? The strings will be, I mean, the strings will be of length 0, that is null. Okay, the strings will be length 3. Okay, because 3 mod 3 is 0. So 3 means A, A, B, A, B, kind of that. Okay, all the strings with length 3. Then the strings with length 6, right? So kind of A, B. Okay, this is one of the string with length 6. Okay, so kind of. Okay, so these are the strings that will be accepted. Now for the starting case, as it is told that the initial, I mean, we are actually having, you know, this null. Okay, as null is being accepted, it means our initial state will be our final state too. Our initial state will be our final state too, right? So let's try to understand whether it is really accepting all the strings with length where the mod of 3 is 0. Okay. So Q0 is representing that the strings with length 0, strings with length 1, strings with length 2. Again, we are going back, strings with length 3, strings with length 4, 5, okay, again 3, 6, 7, 8. Okay, these are all the lengths of the string, right? Let me draw it below. Let me just draw it below. 3, 4, 5, 6, 7, 8, 9, 10, 11. So if you are noticing the pattern, then you can understand that Q0 will have all the strings where the length of the string is divisible by 3. Okay, it is 0, 3, 6, 9, and all. Right. So hence Q0 is our final state for this case. Right. So is it absolutely clear? You can just comment out if there is any question. Okay. So let's come back. Let's come back with our next example. But it is telling now instead of the length of the whole string, we just check the count of we'll just check that the count of a specific symbol. Okay. So here we are checking that the count of A should be of mod 2. Okay, count of A is with mod 2. So it means that all the strings where number of A is either 0, 2, 4, kind of that. Number of A, remember, not we're not depending on number of B, number of A. So how will it look like? It will be if we are getting, I mean, instead of checking with all the characters, we'll just check with A. Okay. If we are getting A, we'll change our state again. By getting another A, we'll come back. Okay. And this will be our final state. So it means that the length of the, I mean, number of A will be here at 0. If you are getting another A, here the length will be 1. I mean, number of A, count of A will be 1. Then count of A here it will be 2, count of A will be 3, count of A will be 4, count of A will be 5. So here you can see that the first, so here you can see that in the first state it is accepting all the strings where length of A, I mean count of A is basically even, right? And for B, what will be the case for B? So for B, basically we won't change our state. Okay, for B we won't change our state, and even if we are getting B, we'll be staying into the same state. Right. Now let's take with another example. So here in this example, basically we need to make sure that number of A and number of B both will be even. Okay. So let's try to draw the automata. So here suppose at this automata, we are telling that number of A is even, number of B is even. Okay. Suppose let's write it like this. Number of A, number of B, both are even. Okay. Now if we are getting A, okay, mind it carefully. Now if we are getting A, then we'll be going to a state where number of A will be odd and number of B will be even. Okay. At this state, number of A will be odd, number of B will be even. Okay. From here, if we get B, then what will happen? Number of A will be even because we are not changing the number of A, but number of B will be odd. Okay, number of A is even, number of B is odd. Right. Now again, if we get A here, then what will happen? If we get A here from even odd, the number of A is even, number of B is odd. Now if we are getting another A, okay, now if we are getting another A, then we can tell that number of A is odd as well as number of B is also odd. Okay, number of A is odd, number of B is also odd. Right. So here you can also check this thing, right? From if number of A is odd and number of B is even, then after that if you are getting another B, then both will be odd, right? And everything will be like bidirectional way. Okay, so this is our final automata, and where the initial state will be our final state because number of A and number of B both should be even. That means the string with length 0, okay, the string with length 0, that will also be accepted. Okay, hence our initial state is our final state, and the initial state will represent that both the count of A and B will be even. Okay, by getting another A, we can tell that the count of A is being odd. Okay, by getting another B, we can tell that the count of B is basically odd, and by getting another A or B from these two states, okay, from like, let me number it, Q0, Q1, Q2, and Q3. Okay, so from Q1 and Q2, respectively, from Q1, if we get A, we'll tell that now the number of A is also even. So that means we will go to Q3. And from Q2, if we get a B, so that we will tell that number of B is also even. I mean, number of B is also getting odd. So we will use to state Q3. Okay. I hope that this example is clear as we move forward. This is the, you know, this is the one of the last examples up to this chapter, and then we'll be moving into some of the gate questions. So it is telling that number of A is divisible by 3. Okay, number of B is divisible by 3. Okay, so it's just like the last example. So in the last example, number of A was divisible by 2, number of B was divisible by 2. Okay, so in that case, we had two remainders. We had remainder 0 and remainder 1. Okay, so that is why we have like kind of, you can say 2 cross 2, we had 4 states. Okay, so for 2 means for the first case, we had 0, 1. For the second case, we had 0, 1. Now in this case, we have, I mean, for here we have like 0, 1, 2. Okay, and for number of B, we will have again 0, 1, 2. So if we have to take both of the conditions, they will we'll just do a cross product and we'll get 9 states. Okay, so what are 9 states? First of all, 0, 0 means number of A is 0 and number of B is 0. Okay. Number of A is 0, number of B is 0. So from here, if we get A, number of A will be 1, number of B is 0. If we get A again, number of A will be 2, number of B is 0. And same with the reverse case. Right? Then if we get B, so we are counting B's into each column and we are counting A's into each rows. Okay. Just see carefully. So if we get another B, it will be 0, 1 because number of B is increasing. By another B, it is 0, 2. Right? And we can come back. Right. Again from here, from 0, 1, if we get another A, if we get another A, we will be at 1, 1. Right? If we get another A, we will be at, we will be at 2, 1. So these are also reversible. Okay. From here, if we get A, we will get 1, 2. If we get another A, we will get 2, 2. Right? These two are also reversible. Now, at this cases, if we are trying to join the column, then you can directly see that from 1, 0, if we get another B, we will get 1, 1. From 1, 1, if we get another B, we will be getting going to 1, 2. So this is basically the transition of B. This is basically the transition of B. And here it is also again transition of B. Okay. So kind of we are ready with our DFA. We are ready with our whole DFA. And we can see that number of A and number of B both will be divisible by 3 only at this stage, okay, at 0, 0 stage, where our initial state is from the final. So please look into the DSM, okay, and let me know if there are any questions. I'll wait for some couple of minutes and then I'll move forward with the game. Okay, so let's start with one of the gate questions. So the first gate question we can see that it is telling that find the number of length 8 strings accepted by the DFA. Find the number of length 8 strings accepted by the DFA. So here we can see what are the paths in which we can accept the DFA. Okay. So from the starting state, we have two paths. One is the path that is started with 0, another one is the path that is starting with 1. Okay. So if we are taking the path 0, then we'll come here, and from here we are dividing into two parts. One is the path with 0, one is the path with 1. So path with 0 and path with 1. Then if we are taking the path with 0, then upon getting 0 or 1, we'll reach here. Okay. So if you're taking the path with 0, there will be again 0 or 1. So kind of, let me just make the tree structure kind of thing. So from the start we have two ways. One is 0 and another one is 1. Then from 0 we have two paths. One is 0, 1. One is 0, 0. Another one is the 0, 1. Okay. So in 0, if we take the path 0, 0, we'll come here, and from 0, 0 we'll again have kind of 0, 0, 0, 1 and 0, 0, 0. Okay. And from if we take the path of 0, 1, then we'll be here, and from here we can say that we have two paths, that is one is 0, 1, 0 and another one is 0, 1, 1. Okay. So upon getting these four strings, we'll be reaching to our final state. Okay. Upon getting these four strings, we'll be reaching to our final state, as well as for 1 also. Okay. If we are starting with 1, then we'll reach here. Okay. And then we have two options. One is to get a 0, another one is to get a 1. Okay. If we are getting a 0, then we'll reach here, and it means 1, 0, and it means 1, 1. And from here also we have two ways. Okay. Upon getting 0, we'll be getting 1, 0, 0. Upon getting 1, we'll be getting 1, 0, 1. And from here we'll be having two options, 0 or 1. So upon getting 0, we'll be having 1, 1, 0. Upon getting 1, we'll be going to 1, 1, 1. Okay. So basically it means we are getting total 8 strings. Okay. You can see these 8 are the smallest strings. These are the smallest strings by which if we are getting these strings, then we will be going to our final state. Okay. Now they're asking that find the number of length 8 strings. Okay. So we can see that by only length 3 string we can reach to the final state, and after that we can basically add anything, 0, 1, anything. Okay, and we'll stay into the final state. So how does it look like? It looks like the first 3 are basically finite. Okay, there will be eight such combinations, and for rest 5, 1, 2, 3, 4, 5, it will be all the combinations of 0, 1. That means 2 to the power 5. What is 2 to the power 5? 2 to the power 5 is 32. So our overall answer will be 8 into 32. So that is 6 to 5. Okay, 256 strings will be there, which are basically accepted by this field. Okay, 256 length 8 strings will be there, which are basically accepted by the field. Okay, now let's see the second question. It is saying that our given language is having only these 3 strings A, B, A, B, A. Then which of the following are the strings that are in L star? L star means basically whatever the strings that we can construct using these 3 uh, substrings. Okay, whatever the strings that we can construct using this substrings. Okay, so the first string, let's try to construct everyone. Okay, so let's give the numbering as this is 1, 2, 3, so that we will understand that which production basically we are going to use. Okay, for the first case, let's try to start with, we have AB, right? We have AB. So let's try to start with our production 1. Okay, production 1. So that we'll be getting, I mean, if we start with AB, yeah. So let's start with production 1. Okay. After that we have AA. So we can use production 2. Okay, I mean the substring 2. Then we have BAA. So we can use substring 3. Okay. Then we have AB. Okay. So we can use again substring 1. Then finally we have AA. So we can use substring 2. Right. So in this way you can see that dividing the whole string into 5 parts, we can just accept. I mean we can say that using these 5 smallest substrings, we can make our bigger string. Okay. Now let's think about the second one. So we have this 4 A's. Okay. So kind of AA. So AA, it means we can use 2. For again AA, we can use the second substring. Right. Then BAA, so we can use the third substring. Then AA, so we can use the second substring. So A is also a correct answer. B is also a correct answer. Okay. Let's try to write. Let's try to check 4. Okay. So for 4, we have started with BAA. So 3. Okay. Then we can use AA. Okay. Then we can use AA. So 2. Then we can use AB. So 1. Then lastly we have AA. So it is 2. Okay. So it means this 4 is also accepted. Okay. 4 can, this string 4, that can be also constructed. Okay. Now let's check about the string 3. It is starting with BAA. Okay. So BAA, we need to give 3. Then it is AA, then AB. So AA means we can use 2. Okay. Because 2 is AA. Then we have AB. So we have to use 1. Okay. Then again we have AA. Okay. So we will use 2. Okay. Then again we have again AA. Okay. So we will use again 2. But after that we are left with B. Okay. We are left with this B, and we don't have a single B here. So we don't have a single B here. So basically this won't be accepted. Okay. 3 won't be accepted, or we cannot construct 3 given the language L. Right. So only 1, 2, and 4. These 3 strings can be constructed by the strings of length L. Okay. I mean by the strings that are in the language L. Is that absolutely clear? Any question? I'll wait for the comment box. let's look into what we have next. So we have this complement of DFA. So couple with example. So we'll just check that how we actually make the complements. Okay. So basically, what is complement? The complement is it will just change the language. I mean, whatever the strings we are being accepting, okay, it will accept the strings which doesn't follow that specific language. Okay. So let's talk with the example. Okay. So the first example can be, even length string and odd length string. So in even length string, what happens? So in even length string, basically, our first initial symbol is the final symbol, final state, and its like double structure is kind of that. Okay. So this state represents the string with a length divisible by 2, and this state represents the string with length not divisible by 2. Okay, it will be odd length. So here the thing you can notice that for even length string, whatever the states we have, for the even length string, the whatever the states we have, for the odd length strings, the states will be complemented. Okay, so the states will be complemented. So the overall situation is like, but if we have tuple structure, in the like in our original DFA, if this is the tuple structure, okay, then in our complemented DFA, the tuple structure will be this Q minus F. Okay, so Q minus F will give us all the states which were previously all the states which were non-accepting. Okay, I mean F is like all the states which are accepting in the previous case, and Q minus F will be the states which are non-accepting in the previous case. Okay, so basically, if this is one DFA, suppose I am writing this as D1, then we will have the D2 if we take the complement. So the D2 will be all the production source will be same. Okay, this A, B, or everything will be same. Only the difference will be in the final state. Okay, only the final states will be changed. Other than that, everything is same. Everything is same. Right. So then we can say that okay, D2 is basically the complement of D1, or vice versa. D2 is the complement. And careful about one thing, that only for DFA, only for deterministic finite automata, this complementation works. Okay, only for deterministic finite automata complement works, but for the non-deterministic finite automata, this complement does not. Okay, complement of this thing doesn't. Okay. Now let's move forward. So now at the subsequent part of today's lecture, we'll be talking about some more a bit complex examples of DFA. Okay, so what is one of the examples that construct a DFA where every A is followed by one B. Okay, every A is followed by one B. So that is like whenever we are getting A, will be followed by one B. Okay, whenever we are getting A, it should be followed by one B. Okay, and again, suppose at this state, if we are getting another A, okay, we'll come back here. And we'll tell that now we have seen one A, so it should be followed by another B. Okay, it should be followed by another B. And if A is followed by A itself, if A is followed by another A, then we'll go to a dead state. Okay, we'll go to a dead state, and we'll tell that let's see, A is followed by A, then this thing is not into the given language. Okay, because A should be followed by one B. So and here number of B can be anything. Okay, and only need to, I mean, we need to consider that after every A, there should not be another A. Okay, to A, this substring should not be there into our acceptor string, right? So if we take all the other condition, then this will be our overall string. Okay, this will be our overall DFA. So yeah, we are done with the construction. Okay. Let's move forward with the next example. The next example is the construct a DFA over AB where A should never followed by B. Okay, so you can see the previous example, it is telling that A should be followed by 1B. Okay, and the next example is it is telling that A should never followed by B. So can you find any similarity between these two questions? What is the similarity? Just comment in the comment section, chat box. What is the similarity between this question where A should be followed by 1B and this question where A should never be followed by B? Is the similarity? The similarity is both of these questions or both of the languages are complement to each other. Okay. So if that is the complement, then what will be the DFA? The DFA will be every state. Okay, every state here. Which are the non-accepting states will be the accepting state, and the states which were accepting. Okay, the states which were accepting will not be unaccepting state. Okay? So it's like the structure will be like this. If we get A, if we get another B, then this state won't be an accepting state. Okay, all other states will be accepting. And for this case, we'll stay here only. Okay. If we get A, that is again fine. If we get A, that is again fine. And this state, okay, this state only accepting. And here basically we can merge these two, we can merge these two states and we can give a self loop here only. Okay, if there are multiple A's, that is fine. Okay, but A should not, okay, but A should not be followed by B. Okay, if it is followed by B, then we'll go to the dead state. Okay. So kind of that, in this way we can think about is this clear? Is there any question? Okay, great. Let's move forward with a couple of examples we have. So here we have another example that we can see that construct a DFA over AB where all the A should come first. Okay, this is like A to the power n, B to the power n. It means all the A should come first, then after that all the B should come first. After that all the B will come, and like number of A and number of B should be greater than equal to 1. So there is one question that why have I written the A and B in the last step. Okay. So basically, the thing is that it is telling that A should never followed by B. Okay, if the question is read correctly, A should never followed by B. So after A, if you are getting a B, after A, if you are getting a B, you should be going to a dead state. Okay, dead state means this is a non-accepting state, and our language will never be accepted after that. Okay, I mean our string will be accepted after that. So after A, if we are getting a B, then we will be going to such a state from where we should not go back. Okay, I mean from where if we are getting either A or B anything, then we should not go back. Okay, so that is why it is a dead state. It is a dead state, and I have written the self loop. Okay, it is a dead state, and in dead state, obviously there is a self loop because we should not stop our execution, right? We should not stop our execution. Whether we are getting A or B, we can guarantee that we can guarantee that we will not go to the final steps. Okay, we'll stay here on. Stay here on. Fine. Now let's talk about this example. A of number of A and number of B both will be greater than one. Okay. So the thing is that both are greater than one, then we can call that all the A should come first. Suppose there can be zero. There can be one A. After that, there can be multiple A's. Okay. It means at this position, we can tell that we have got more than one, I mean one or more than one A. And from here, we can get another B, or we can get another multiple B's. Okay. Right. So this is our uh, DF. Now there will be certain dead states. Okay, but I mean dead condition. What is the dead condition? Suppose before getting any A, we are getting a B. So before getting any A, we are getting a B. So that means we will go to a dead state. So because that's not acceptable. So before A, we should be getting. Before B, we should be getting at least one A. Okay. So this is one dead state, and here also for this music state, everything is defined. We have defined for A, we have defined for B. Now at this end state, if we can get A, okay, for this end state, if we are getting A, then what will happen? That after B, after all the B's, we are getting an A. Okay, that means again it is a dead state. After B, if we are getting A, so then again we will go to the dead state. Right? Because that is not again acceptable. All the A should come first, then all the B should come. Right? So this is our final B. Next. So that is one. And then we'll move to the next question, next DFM. So it is the same question with the certain difference. The difference is that now A and B can be zero. A and B can be zero. With certain differences there, right? So let's see how should we tackle it. So if both are zero, okay, number of A and number of B both if B if both are zero, then that is null. Okay, null will also be accepted. So let's check it out. So if null is accepted, then our initial state will be final state, right? And from here, if we're getting one A, okay, from here, if we are getting like multiple A, it will be accepted. Then if we are getting B, then again if we get multiple B, that is again accepted. I mean, see, the difference is that all the A's should come first. Okay, all the A's should come first. So, I mean, we can accept for any number of A. But whenever we are getting at least one B, then we should be getting all the B's. Okay, whenever we are getting at least one B, that means we should ensure that now our all the A's are done, and now we are getting B. Okay, and after getting B, if we are getting any other, after getting all these, if we are getting any other, then that okay, this is not acceptable. Okay, all the A should come first, then all the B should come, then then that's it. Okay, after that, if you are getting any other A, that's not acceptable. That is the dead state. That is the dead state. Fine. So this is our, you know, this is our overall DFA structure. Okay. Is there any question till this point? Is there any question? So, so yeah, we are at the end of today's class. So basically, we looked over some couple of many DFA examples with couple of gate questions as well. So thank you for joining in. This gate crash course, I will repeat. So this gate crash course is absolutely free, and we should be like for the if you're in mid of your preparation, then you can just have the gate crash course as the I mean, you can start your revision using the gate crash course. And other than that, if you have not started or if you are like at the very early stage of your revision, I mean preparation, then you can also go for this crash course and you can like just get a bit of understanding that what are the things you should be knowing, what are the things you should prioritize before others. Right. So thank you for joining in. If there are any more questions or any more general things, then please comment it out. Otherwise, I close the session with. So please comment it out so that I'll address them. Okay. So I believe there is no question. Okay. Please do check out the Gate crash course. Okay, link is in the description or link is pinned in the description. So thank you for joining in. I hope it was a very I mean you got a basic understanding of this DFA and the regular grammar. So hope to see you in the next session. Thank you.